In the summer of 1978, thousands of people were working inside one of New York City's newest skyscrapers. They had no idea that engineers were preparing an emergency evacuation plan for the building and for the streets surrounding it. During the day, the tower operated normally. At night, workers opened its walls and floors, surrounded critical steel joints with temporary plywood enclosures, and welded reinforcements into place before the employees returned the next morning. The building was Citicorp Center, now known as 601 Lexington Avenue. Completed in 1977, the 59-story, 915-foot tower was one of the most recognizable additions to the Manhattan skyline. Its silver exterior, sharply sloping roof, and enormous open base made it look as if a skyscraper were floating above the city. That appearance was created by an extraordinary structural problem. St. Peter's Lutheran Church owned part of the block and agreed to the project only if a new independent church could remain at one corner of the site. A conventional skyscraper would normally place its largest supporting columns near the corners, but one of those corners had to remain free. Structural engineer William Lemessurier developed a daring solution. Instead of supporting the tower at its four corners, he placed four massive, 9-story-high columns beneath the center of each side. The corners of the building extended outward beyond those supports. Inside the tower, enormous diagonal braces formed stacked chevrons, transferring wind forces and the building's weight toward the four unusual columns. It was elegant, efficient, and unlike almost anything previously built. But the structure was also unusually light, and tall buildings move in the wind. To reduce that movement, engineers installed a tuned mass damper near the top of the tower, a roughly 400-ton block designed to move against the building's sway. When wind pushed the tower in one direction, the enormous mass resisted the motion, making the building more comfortable for the people inside. The skyscraper opened, attracted international attention, and appeared to be an engineering triumph. Then, in 1978, two separate questions began pulling at the confidence beneath the design. During work on another building, Lemessurier learned that critical joints in Citicorp Center had not been constructed exactly as he originally specified. His design called for full-strength welded connections in the tower's giant chevron braces. During construction, however, bolted connections had been substituted. Bolting was faster and less expensive, and the change had been accepted within the project team. For the wind loads used in the original calculations, the bolted joints appeared adequate. But another question had emerged. Students studying the unusual tower had raised concerns about winds striking it diagonally toward a corner rather than directly against one face. These are known as quartering winds. Because a diagonal wind interacts with two sides of a square building at once, Lemessurier decided to examine the forces more closely. According to the calculations he performed in 1978, quartering winds increased the stress in some structural members by approximately 40%. At certain bolted joints, the calculated effect was far more severe. The combination of the unconventional bracing system, the diagonal wind assumptions, and the substituted bolted joints led Lemessurier to believe that the newly occupied skyscraper had a potentially catastrophic weakness. The tuned mass damper offered some protection, but it depended on electrical power. A hurricane could produce extreme winds while also causing a blackout. If the damper stopped operating at the worst possible moment, the building would lose an important source of stability. Lemessurier's assessment was terrifying. He estimated that with the damper operating, the dangerous combination might occur roughly once every 55 years. Without the damper, he believed the risk could rise to approximately once every 16 years. That did not mean the building was expected to collapse every 16 years. It meant that the estimated wind threshold associated with the feared failure had an annual probability far too high for a major occupied skyscraper. And the discovery arrived during hurricane season. Lemessurier now faced a decision that could destroy his career. He could remain silent, hope the calculations were overly conservative, and protect his reputation. Or he could reveal that one of the world's most celebrated new buildings might require emergency structural reinforcement. On July 31, 1978, he began contacting lawyers, insurers, other engineers, and the people responsible for Citicorp. Independent structural engineer Leslie Robertson reviewed the situation and treated it as a genuine emergency. Citicorp's leadership was informed. City officials were brought into the plan. Meteorologists were hired to monitor approaching storms. Emergency generators were arranged to keep the tuned mass damper operating if the city lost power. And planners prepared for the possibility that the tower and a large area around it might need to be evacuated. The proposed emergency response involved as many as 2,000 workers and covered an area extending several blocks around the building. But the occupants were not told the full story. Public statements described the work as reinforcement designed to handle higher winds. Most employees continued entering the tower every morning without knowing why parts of the building were being opened during the night. The repair itself was conceptually simple but operationally enormous. Workers exposed the critical bolted joints hidden behind floors and walls. Heavy steel plates were positioned across those connections and welded into place, creating what the engineers informally described as structural band-aids. Temporary plywood rooms concealed the work and contained the heat, light, and debris. Crews welded through the night. Before morning, work areas were closed again so the building could return to normal business. This continued floor by floor, joint by joint, while weather teams watched the Atlantic. In early September, a hurricane began moving in a direction that caused serious concern. The tower was only partly reinforced. The tuned mass damper was being monitored continuously. Emergency preparations stood ready. Then the storm changed course and moved back over the ocean. The welding continued. By the middle of September, enough reinforcement had been installed for officials to relax the evacuation preparations. The repairs were completed the following month. The tower was now stronger than the original design had intended, even if the tuned mass damper lost power, and the entire operation remained largely unknown outside the people directly involved. A citywide newspaper strike reduced press attention at a crucial moment. The full story did not become widely known until a detailed investigation was published in 1995, 17 years after the repairs. For decades, the Citicorp crisis became one of engineering's most famous ethical lessons. Le Mesurier was praised for confronting the danger, reporting it, and helping organize an urgent repair instead of hiding from professional ruin. But the story also raises harder questions. Why was such a critical construction change not fully reconsidered at the highest design level? Why were thousands of occupants kept unaware of the emergency? And should an engineer receive only praise for correcting a danger connected to his own design and oversight? There is another complication. Modern researchers at the United States National Institute of Standards and Technology have re-examined a similar structural design using computational tools unavailable in the 1970s. Their analysis found that winds striking the face of the building could be more demanding than diagonal winds. That does not mean the emergency repairs were imaginary or that reinforcing the bolted joints was a mistake. It means the popular explanation that quartering winds alone revealed a tower on the edge of collapse may be incomplete, and the precise historical risk deserves further examination. That uncertainty makes the story more important, not less. Engineering decisions are rarely made with perfect information. In 1978, the people responsible had an occupied skyscraper, alarming calculations, an approaching hurricane season, and no safe reason to wait for decades of future computer analysis. They chose to reinforce the structure. Today, the building stands safely at 601 Lexington Avenue and is protected as a New York City landmark. Its silver surface reveals nothing about the steel plates hidden behind its walls, the welders who worked while the city slept, or the evacuation plans that were prepared but never used. The tower did not become famous because it collapsed. It became famous because someone looked again, and because a hidden weakness was confronted before the world discovered it in the worst possible way. Every great structure has a story beneath the blueprint. Subscribe for more hidden systems, engineering failures, and decisions that quietly change the world.